Hi guys, today we are working with population parameters. So we're still talking about statistics, but today specifically we're going to identify and apply population parameters. And that means like mean, median, standard deviation, things like that. So some things you're familiar with, mean and median, and then some things that maybe you've had before and maybe you haven't. So a lot of the work that we're going to do is going to be done for us by a calculator or online. So I don't have a calculator at home. I know a lot of you don't have a calculator at home. So one of the things you're going to do is you're going to click on this link when you're on my calendar, even if you've printed it, just go back and click on that link and you're going to be able to use that for every single problem for the note catcher and the work time. So when you do that, we're going to use that information for exercise number 1. There are 18 students in Mrs. Weiler's advanced calculus class, and they took a quiz, and these were their results in order. So it says to use your calculator or the website, and again, I used the website, to determine the mean, median, and quartiles for this data set, and then construct a box and whiskers plot. So if you type this into the website, there's a place where you can use raw data, or there's a frequency table option. Right now, you're going to want to use raw data. You're going to type every single number in, you tab in between them. When you do that, then at the end, you can use, you can hit, I think it's a calculate button, but you hit the button at the bottom and it gives you all this information. So your mean for number 1 is 83.7. If you had added all those up and divided by 18, you would have gotten 83.7, but the calculator does it for you. The median is just the middle number. As you work your way into the middle, it's the middle number. And here it's between 84 and 85, so it's 84.5. Again, the website does this for you, but that's how you would normally calculate median. So then the first quartile is written on it's on that website. It's one of the things that comes up as 75, and the third quartile is 93. So how do you convert that to a box and whisker plot? Well, what you do is you set up a graph with your lowest point and your highest point. So 56 to 100, and they go there. And then I've kind of marked the little, every 10, I made a little bit larger of a line. And then I marked my median, which was 84.5. I marked my first quartile, which was 75. That means 1/4 of the data. And then I marked my third quartile, the beginning of it, because the mean is the second quartile. It's in the middle. And then this is the top 4th. So it's 93. Again, all that is just from this data that you got from the computer. You don't have to calculate it. But you have a box from the first quartile to the third with a line where the median goes. And then you do the whiskers out to the low and the high. All right, so this is a familiar type of graph. You've done box and whisker plots before, or probably have. I would assume you have in middle school probably, so it's been a while. All right, so what is the interquartile range of this data set? Well, if you look at your data on the computer, it tells you it's 18, but I wanted to show you that you could get that even if it didn't tell you the interquartile range was 18, because the way you find it is you take quartile 3, the third quartile, minus the first. So in other words, 93 minus 75, the box. So the high end of the box minus the low end of the box. And so it's 18, but it was actually already given to you by the online program. But that's how you find it. So in theory, about 50% of your data, or about half of it, should fall inside this box, right? And then 1/4 should be below, and 1/4 of the data should be above. But 50% should fall within this, in theory. But in reality, there are 8 numbers in that list that are between 75 and 93. So if we go back up to the list, between 75 and 93, if you don't count those, there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 data points out of the 18 total that fall within that quartile. And if you divide 8 divided by 18, you get 0.44, or about 44%. So that is how much falls in between the quartiles, 1 and 3. All right, so that's the interquartile range. So C, what is the population standard deviation to the nearest tenth? Again, you can look at the information that was populated after you typed your data in on the computer, and it tells you it's about 12. So what does that mean? That means on average, a data point lies about 12 units away from the mean, on average, okay? So why do we care? Well, down in part D, we want to find what is within 1 standard deviation of the mean. So we take the mean, which we know from up there is 84.5, and we add and subtract the standard deviation, which is 12. So that means 84.5 minus 12, 84.5 plus 12. So that means that we should have 1 standard deviation away is all the numbers between 72.5 and 96.5. So again, we go up here to our data, 72.5 and 96.5 means that we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means that there were 11 out of 18 that were within 1 standard deviation of the mean. And so that's about 61%. Remember, in theory, it should be right around 50 possibly, but in this one, it is 61. Now, within 2 standard deviations, so again, you just multiply the standard deviation by 2, so it's 12. So instead of subtracting and adding 12, you subtract and add 24 from the mean to find out what's within 2 standard deviations. And you find that it's actually 17 out of the 18 numbers, or 94%. Most of your data will fall usually, you never know because data is all different, within a very high percentage. So in this case, 94%. All right, page 2. So sometimes we use a frequency chart instead of using a list of numbers. So on the website that I gave you, you can use raw data and just type these in and type 25,000 in 5 times, 32,000 in 21 times, 45,000 in 14 times, or you can switch over to the next thing, which is a frequency table, and type in 25,000, and then it happens 5 times. So you put in a 5, and then 32,000, and then 21. So you can literally type it straight from this chart. Now, just to note, there are 50 total numbers in this chart if you add up the frequency. So again, you just look at the data that you generate from the computer, and the average or mean, which is represented with an X with a line over it because the average of X is 42,060. The standard deviation, which is this Greek symbol with a little subscript of an X, is 16,736. It says, what is the median and why is it so much lower? Well, 32,000 is the middle number in this data set out of the 50. But that's just because it's just the middle number. It's the 25th number out of 50. And so the 25th number is 32,000. But the mean is higher because you have a couple of these random higher salaries. And so the mean is adjusted, it's skewed a little bit higher because of those higher salaries. So part C, does more or less than 50% of the data fall within the 1 standard deviation of the mean? Show how your analysis to lead to your answer. So we did the mean minus 1 standard deviation and got 25,324. And we did the mean plus 1 standard deviation and got 58,796. Well, 25,000 isn't in there, but 32,000 is in there 21 times. 45,000 is in there 14 times. 58,000 is in there 7 times. And 75 takes us above this number. So we have a total of 21 plus 14 plus 7 numbers. That makes 42 out of the 50 numbers are within this range right here of 1 standard deviation away from the mean. So that means 42 divided by 50 is 84%. So 84% of the salaries fall within 1 standard deviation of the mean, which is actually much higher than 50%. All right, I hope that you found that helpful. Please use this information and that website to help you with your work time. Please remember, I am available every day except for Wednesdays when I do live instruction. Every other day, I'm available from 2 to 2:30 to answer any questions you might have. Have a great day. See you soon.